Today we're looking at notes L-3, coterminal, complementary and supplementary angles, all in radians. So here you have before you a circle that has its angle measurements in radians. So remember, this is our initial side, our starting point right here, 0 radians. And then when you come up here to what would be called 90 degrees, that's our pi over 2 radians. Okay, where this is our pi radians. And if you recognize that each 90 degrees is counting by like half of pi, this is half of pi, this is 2 halves of pi, this is 3 halves of pi, and this is 4 halves of pi, or in other words, 2 pi, which is a full revolution. So a full revolution is 2 pi, and what would be the same as 180 degrees would be just a single pi, just pi. Now I've also cut this up into fourths, just so you can see what the 45 degree pieces would look like in radians. So this is your pi over 4, which is the same as 45 degrees. And then if you're looking at the circle in terms of fourths of pi in radians, this would be 1/4 of pi, this would be 2/4 of pi, which is a half. This is 3/4 of pi, and then this is 4/4 of pi, which makes it a whole pi. This is 5/4 of pi, 6/4 of pi, which is 3 pi over 2, 7/4 of pi, and then of course 8/4 of pi, which makes it back to our full revolution of 2 pi. So sometimes you'll want to think in terms of the fourths, sometimes you'll want to think in terms of the halves, and then later when we talk about it, we'll talk about thirds and sixths, etc. So, but for today, do your best estimation with what you know. So draw each angle in standard position, and of course we're talking radians. So if theta is given to you on number 1 as pi over 5 radians, it does kind of interest you to think about pi over 4, because pi over 5 is a little bit less than pi over 4. So it's not quite that 45 degrees or pi over 4, it's a little bit less. So maybe approximately that. Okay, if I want to draw 13 pi over 12, well, think about how many times does 12 go into 13? So 12 goes into 13 one whole time with 1 left over. So this is like 1 and 1/12 pi. So we've got a full 1 pi, but then a 12th more. A 12th is a very, very small amount. So it's just a little bit more than that pi radians. So remember that pi is here, so it's just a little bit more. Definitely not quite to there. So then looking at number 3, 11 pi over 15. This is kind of a funky one. So with this, really just think in halves and get as close as you can get. So you're talking 11 over 15. Of course, that's more than a half of pi, yes? Because a half would be like 7.5 over 15, and 11 is more than 7.5. So this is a little bit more than a half of pi, but definitely not quite a whole of pi. So you're talking like about there, because like I said, it's a little bit more than a half of pi, but not quite a full pi. So that would be a great drawing for that. When you're talking 11 pi over 6 is the angle measure given, 11 pi over 6, so it's almost, think about 12 pi over 6, that's almost a full revolution, that's almost 2 pi. It's getting real close to doing that full revolution, but not quite. So you're talking something that looks like this, okay, because 6 goes into 11 once with 5 remaining, so 5 pi over 6. So really close to that full revolution there. Okay. All right, so now let's recall coterminal angles. And again, we're thinking radians today. So remember that coterminal angles look like they might be the same angle. They've got the same initial side and the same terminal side, but one might have gone around a full revolution more, or 2 full revolutions, or, gone in the other direction. So remember that about coterminal angles. They look the same, but they have different angle measures. So your plan to get two coterminal angles, one positive and one negative, is to add or subtract a full revolution. And remember that a full revolution is 2 pi. So given that theta, or your angle measure, is pi over 3, we're going to take pi over 3 and we're going to add a full revolution. So add 2 pi. Remember, you have to get a common denominator, so this is like 2 pi over 1. So in other words, pi over 3 plus multiply by 3, you'd get 6 pi over 3. So that would be 7 pi over 3. Pi plus 6 pi is 7 pi. Keep the denominators the same. So these two angles are coterminal angles. That was my positive. Now I need to get my negative. So pi over 3 minus my full revolution of 2 pi. That would look like pi over 3 minus 6 pi over 3. So 1 pi minus 6 pi would be negative 5 pi over 3. So that's my negative angle. So then given theta as negative 3 pi over 4, so then you would take negative 3 pi over 4 and you would add your full revolution, so add 2 pi. In this case, we need a denominator of 4. So negative 3 pi over 4 plus 8 pi over 4. Negative 3 pi plus 8 pi is 5 pi, so 5 pi over 4. There's our positive coterminal angle, and now let's find our negative. So negative 3 pi over 4 minus our full revolution. Okay, so negative 3 pi over 4 minus 8 pi over 4, which would be negative 11 pi over 4. So there's our negative. Last but not least, given theta of negative 15 pi over 6, we will add our full revolution, so negative 15 pi over 6 plus 2 pi, which is really like negative 15 pi over 6 plus 12 pi over 6, which would be negative 3 pi over 6, which would end up being negative pi over 2. Notice when I added the revolution, I still got a negative angle. So that can be our negative angle, and we can take that, and now we can add a full revolution to that, and that would be our positive. So we've got negative pi over 2, add 2 pi, so negative pi over 2 plus 4 pi over 2, which would give us 3 pi over 2. So now for this given theta, I have both a negative and a positive coterminal angle. So that's coterminal angles. Let's refresh complementary and supplementary. So remember that complementary angles add up to 90 degrees, or in our case with radians, it's pi over 2 radians. Supplementary angles add up to 180 degrees, or in our case for today, since we're dealing with radians, pi radians. So our plan is still as it was with degrees. Take the target angle and subtract the given angle. So for complementary, my target angle is pi over 2. So take the pi over 2 and subtract the given pi over 12. So multiply by 6 and 6, so I get 6 pi over 12 minus pi over 12. So it would be 5 pi over 12. So 5 pi over 12 plus pi over 12 equals pi over 2. Those two angles are complementary. Supplementary, right here, supplementary would be pi minus the given. So the given is pi over 12. So this would be 12 pi over 12 minus pi over 12, which would end up being 11 pi over 12. And that box kind of is getting in the way here. So 11 pi over 12 would be for supplementary. Okay, number 2, theta given as 5 pi over 8. So for complementary, we would have pi over 2 minus 5 pi over 8. So multiply by 4 on numerator and denominator. 4 pi over 8 minus 5 pi over 8. Remember, we can't have negative angles here, so we'd have a negative angle that's not allowed. Okay, so we're going to say none here. Okay, for supplementary though, let's see if that'll work. So we're going to take pi and subtract 5 pi over 8. It'll definitely work. So 8 pi over 8 minus 5 pi over 8 would give us 3 pi over 8 for supplementary. So 3 pi over 8 and 5 pi over 8 are supplementary. They add up to pi radians. Last but not least, you may be given theta in radians without the pi, already converted to a decimal, so 2.9 radians. So for complementary, you would just do pi over 2 still minus 2.9. You would plug that in the calculator, and the calculator will give you a negative answer. So again, that's not allowed. None. Okay. When you do supplementary for this, you have pi minus 2.9, and you'll know that's going to work out because pi is 3.14, blah, 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 blah. So when you plug that in the calculator, you get, when you round to the thousandths, 0.242 radians. So 0.242 and 2.9 add up to pi radians.